This tutorial explains how to annotate a star wheel to show the ecliptic, which is the path taken by the Sun, and the regions of circumpolar, rise-set, and never-rise stars. First, some background and prerequisite knowledge is reviewed. Then star wheels are introduced. Instructions for annotating the ecliptic line are provided. Then the summary of formulae derived in previous lectures is given. These formulae are applied to star wheels to determine the observability of constellations from a location. Examples of how to do this, for 2 different northern latitudes are given.
Students who are new to astronomy should complete the tutorials The Earth Spins on Its Axis before doing this tutorial. The following terms are used: latitude, celestial equator, north celestial pole, south celestial pole, and declination angle. To determine observability, the site latitude must be given. Lines of latitude are parallels running in an east-west direction, that measure distance north or south from the equator. The equator is a great circle, and has latitude of 0 degrees. The equatorial region runs from roughly -30 degrees, 30 degrees south, to +30 degrees. The northernmost latitude, 90 degrees, is the North Pole, and is a single point. Mid-latitudes in the northern hemisphere are from 30 to 60 degrees. Arctic regions are above 60 degrees and below -60 degrees. Lines of declination on the celestial sphere are analogous to lines of latitude. To determine observability, the declination of the star must be given. Lines of declination are parallels running in an east-west direction, that measure distance north or south from the celestial equator. The celestial equator has a declination of 0 degrees. Stars with positive declinations are in the northern celestial hemisphere. A declination of +90 degrees is the north celestial pole. Polaris is a star in the Little Dipper that is so close to the north celestial pole, it can be used for navigation. Stars with negative declinations are in the southern celestial hemisphere. There is no star close to the south celestial pole. Lines of declination on the celestial sphere are analogous to lines of latitude. To determine observability, the declination of the star must be given. Lines of declination are parallels running in an east-west direction, that measure distance north or south from the celestial equator. The celestial equator has a declination of 0 degrees. Stars with positive declinations are in the northern celestial hemisphere. A declination of +90 degrees is the north celestial pole. Polaris is a star in the Little Dipper that is so close to the north celestial pole, it can be used for navigation. Stars with negative declinations are in the southern celestial hemisphere. There is no star close to the south celestial pole.
A star wheel is a celestial coordinate map, RA/DIS, of the stars with a separate moving overlay that has a window for the horizon of visible stars above an observer. To use the star wheel, orient the time of day on the horizon window to the day of the year on the star wheel. The referenced Sky and Telescope article provides templates for their star wheel and instructions on its use. The sky wheel has a declination and hour angle grid. This is a polar projection of the celestial sphere's polar coordinate system. The lines of declination are concentric circles. The dot at the center of the wheel is the north celestial pole, with Polaris. The smallest inner circle is +80 degrees declination. And each larger concentric ring is 10 degrees less in declination. The largest circle is a declination of -40 degrees. The ecliptic is the path taken by the Sun throughout the year. The apparent motion of the Sun, against the fixed stars on the celestial sphere, as seen from Earth, is a constant motion towards the east at slightly less than 1 degree per day. Because the Earth's spin axis is tilted with respect to the plane of its orbit around the Sun, the path is tilted on the celestial sphere. At the intersection of the ecliptic and the celestial equator, the length of day and night are equal, and these points are known as equinox points. Thus, on the vernal and autumnal equinox, the declination of the Sun is 0 degrees. On the summer solstice, when the amount of daylight is longest for the northern hemisphere, the declination of the sun is 23.5 degrees. On the winter solstice, when the amount of daylight is shortest for the northern hemisphere, the declination of the sun is minus 23.5 degrees. Find the points on the star wheel for the sun's position on the equinoxes and the solstices. Draw a freehand sketch of the ecliptic through these special points. This is the path of the ecliptic. Since the solar system is relatively flat, the planet positions and the position of the moon are not very far from this line.
Stars, as observed from a particular site, can be classified as being circumpolar stars, meaning they are always in the sky, rotate counterclockwise once per day around Polaris, or as rise/set stars, meaning they rise and set once each day and are seasonally in the night sky, and never rise stars. These are mutually exclusive characterizations of observability, and depend on the latitude of the observation site. University of Nebraska's Rotating Sky Explorer shows stars on the celestial sphere and in a local horizon coordinate system. Here for Nashua, NH, we can see that the Big Dipper is a circumpolar constellation, Orion rises and sets, and the Southern Cross is in the never rise region. In previous lectures, we derived the relationships for circumpolar and never rise stars. If the sum of the declination and latitude is greater than 90 degrees in the northern hemisphere, the star is circumpolar. If it is less than minus 90 degrees in the southern hemisphere, it is circumpolar. If the difference between the declination and latitude is less than minus 90 degrees in the northern hemisphere, the star never rises. If it is greater than 90 degrees in the southern hemisphere, it never rises. Stars that are neither circumpolar stars nor never rise stars are rise/set stars. They are observable seasonally in the night sky. These classifications are site-specific and mutually exclusive. The University of Nebraska has a simulator that shows which declination regions of the celestial sphere are circumpolar, which are rise/set, and which are never rise for a given latitude on Earth. We see the regions are divided at two declinations plus and minus the absolute value of 90 minus latitude for the northern hemisphere viewer and plus and minus the sum of 90 and latitude for the southern hemisphere.
So you might think that the easiest way to determine constellation observability would be from a rectangular map of declination versus right ascension. Such a map is analogous to the equal rectangular map projection of Earth. If we wondered which countries were north of 45 degrees north latitude, we would just draw a line and see that part of USA, Canada, Greenland, most of Europe, Russia, and China are above that latitude. In 1922, Henry Norris Russell aided the International Astronomical Union in dividing the celestial sphere into 88 official constellations. In 1930, the boundaries between the 88 constellations were devised by Eugen Delporte. This equirectangular plot of declination versus right ascension of the modern constellations has a dotted line denoting the ecliptic and a faint map from NASA of the Milky Way galaxy. Constellations are color-coded by family and year established. For an observer at latitude 45 degrees north on Earth, the regions of declination above 45 degrees are circumpolar. Regions between 45 and minus 45 degrees north rise and set, and are seasonally in the night sky. Regions with declination below minus 45 degrees never rise and are not observable at any time from the latitude 45 degrees north. However, these map projections are impractical for nightly viewing. Here we can use the app MapFi to show the degree of distortion. Overlaying Greenland and Mexico shows that they are close in size, whereas the area on the maps are quite different for these countries. It's easy to understand the distortion when you realize the top and bottom lines on the map are really points on the globe at the North Pole and the South Pole. Likewise, the top and bottom lines on the equal rectangular map are single points on the celestial sphere, the North Celestial Pole and the South Celestial Pole. The distortion imposed by this projection on our nightly view is evident in the constellation Ursa Minor, where the Polaris star is fragmented from the handle of the Little Dipper. The distortion arises from the ways that shape, direction, distance, and area of a three-dimensional surface are visualized on a two-dimensional surface. For evening viewing, azimuthal equidistant projections are used since they preserve distance along any line through the center. The United Nations logo is an azimuthal equidistance projection. These are the projections of star wheels. In this activity, star wheels are annotated for use during observing.
To determine which constellations are circumpolar from your observation site, print out the Northern Celestial Hemisphere and Southern Celestial Hemisphere star wheels. Color the different regions. The next two slides explain how to do this, and then two examples are given step by step. Determine which constellations are in the circumpolar region. Use the star clock to find the Dippers and Cassiopeia in the night sky. Navigate between these constellations to find the other circumpolar constellations. Then look along the ecliptic line for the zodiacal constellations. Again, the sky wheel has a declination and hour angle grid. This is a polar projection of the celestial sphere's polar coordinate system. The lines of declination are concentric circles. The dot at the center of the wheel is the North Celestial Pole, with Polaris. The smallest inner circle is plus 80 degrees declination. And each larger concentric ring is 10 degrees less in declination. The largest circle is a declination of minus 40 degrees. For a northern hemisphere observation site, the condition for circumpolar stars is that the declination must be greater than the difference of 90 degrees and the site latitude. For the southern hemisphere, this value is the difference of minus 90 degrees and the latitude. If this declination is between minus 40 degrees and 90 degrees, sketch or use a compass to make a circle marking this value. For a Northern Hemisphere observation site, the condition for never-rise stars is that the declination must be less than the difference of the latitude and 90 degrees. For the Southern Hemisphere, this value is the sum of the latitude and 90 degrees. If this declination is between -40 degrees and 90 degrees, sketch or use a compass to make a circle marking this value. The skywheel has a declination in our angle grid. This is a polar projection of the celestial sphere's polar coordinate system. The lines of declination are concentric circles. The dot at the center of the wheel is the south celestial pole. There are no bright stars close to the south celestial pole. The smallest inner circle is -80 degrees declination. And each larger concentric ring is 10 degrees greater in declination. The largest circle is a declination of +40 degrees. Repeat the previous direction of annotating the circumpolar and never-rise declinations for the Southern Hemisphere. Then determine visually which constellations are circumpolar. For example 1, the observation site is at +60 degrees north. Thus the circumpolar declination is 30 degrees and the never-rise declination is -30 degrees. First draw the circumpolar declination line on the Northern Hemisphere. Notice that the lowest declination is -40 degrees, so that the rise/set declination can also be plotted on the chart. Draw the rise-set declination line. The region between the circumpolar and never-rise declinations has stars that rise and set once each day. Shade the rise-set region green. Stars with a declination greater than the circumpolar declination line are circumpolar stars. Shade this region red. These are the circumpolar constellations as observed from 60 degrees N latitude. Visually, it can be determined that Ursa Minor, Draco, Ursa Major, Auriga, Camelopardalis, Andromeda, Perseus, Cassiopeia, Cepheus, Lynx, and Lyra are circumpolar from a latitude of 60 degrees north. The stars that have declinations lower than the never-rise declination line are never-rise stars. Shade this region blue. Now repeat for the Southern Hemisphere. The highest declination is +40 degrees, so the circumpolar declination line of 30 degrees can be drawn on the southern wheel as well as the northern wheel. Draw the never-rise line at -30 degrees declination. Shade the declinations that are greater than 30 degrees red. This is the circumpolar region at a +60 north latitude observation site on the southern wheel. Although some constellations are evident, this region is incomplete since the declinations from 40 to 90 degrees are missing. This information is incomplete and redundant to the red region of the northern wheel. The region between the rise/set and the circumpolar declination are the rise-set stars. Shade this region. Now shade the inner circle of declination values less than -30 degrees blue. These are the never-rise constellations as observed from a +60 north latitude site. The second example shows the observability from a site at a geographic latitude of 45 degrees north. The circumpolar declination line is 45 degrees, and the never-rise declination line is -45 degrees. Here, we'll see a case where only two regions are on each hemisphere. Sketch the circumpolar declination line of 45 degrees on the northern wheel. Notice that the never-rise declination is -45 degrees, which is lower than the lowest declination on the northern wheel. It can't be drawn. The region of declinations greater than the circumpolar declination line are circumpolar stars as seen from a latitude of +45 degrees north. The rest of the stars on this chart are rise/set stars as seen from a latitude of +45 degrees north. Visually, it can be determined that Ursa Minor, Draco, Ursa Major, Cassiopeia, and Cepheus are circumpolar from a latitude of 45 degrees north. Now shade the southern wheel. Notice that the circumpolar declination of +45 degrees is higher than the highest declination on the southern wheel. It can't be drawn. Sketch the never-rise declination line of -45 degrees. Stars with declinations less than the never-rise declination line are never-rise stars. They can't be observed from a latitude of 45 degrees north. The rest of this plot are rise/set constellations as seen from plus 45 degree latitude. The region of declinations greater than the circumpolar declination line are circumpolar stars as seen from a latitude of plus 45 degrees north. The rest of the stars on this chart are rise/set stars as seen from a latitude of plus 45 degrees north. Visually, it can be determined that Ursa Minor, Draco, Ursa Major, Cassiopeia, and Cepheus are circumpolar from a latitude of 45 degrees north. Starting with the Northern Hemisphere chart, add the ecliptic line to assist in nighttime observations.
These websites were used for the production of this video.